Okay, we're now actually going to start look at doing hypothesis tests. Now, in this first example, they've already done the test for us, and here are the results of the hypothesis test over to the side. So we're going to just interpret this data over here to answer these questions. And in the next video, we're actually going to conduct our own hypothesis test. Actually, no, I think we've got a few more examples first, but we'll get there. We're looking at a drug that's used to treat asthma. In the clinical trial, 28 of the 295 treated people experienced headaches. The accompanying calculator shows the claim that less than 11% of the treated subjects experienced headaches. Use the normal distribution as an approximation to the binomial and assume a 0.01 significance level. That's important, and we'll complete the parts below. So before we even do this, notice that this is a proportion because you either have a headache or you don't. So if I do 28 divided by 295, we get that about 9% of people got headaches, just based on the data. So we can see that that's less than 11%, but the question is it less than 11% enough to reject the null hypothesis? Because 9% is pretty close to 11%, and maybe it's possible that we could have gotten this result just by chance. So let's look at the data. First off, is the test two-tailed, left-tailed, or right-tailed? Two-tailed means it's not equal to, left-tailed means less than, and right-tailed means greater than. Okay, so the accompanying calculator, we're testing the claim that less than 11% of treated subjects experienced headaches, so that means it's a left-tailed test. Left-tailed is less than, not equal to is two-tail, greater than is right-tail. What is the test statistic? We get our test statistic by looking at this. Now, it's kind of confusing because there's a lot of p's running around. P hat is our test statistic, whereas p is just the p-value. So p is the p-value, p hat is the test statistic. Okay? So the test statistic is equal to the oh, I'm sorry, I got it incorrect. I made a mistake. My apologies. The test statistic is either a z, a t, or something like that. I got my wires crossed. This is the actual proportion we got from the actual test. You see, I calculated this number myself. I'm sorry about that. So here's the actual proportion. So is 0.09 different enough than 0.11? Well, our test statistic is negative 0.828, rounded to 3 decimal places. Or if you want to round it to 2 decimal places, it would be negative 0.83. In fact, that's the number that the book has, so I'll go ahead and box that. Notice that this test statistic is negative. That will always happen when it's a left tail. If you're looking at the left tail, it will be a negative test statistic, which is why we need to take the absolute value of it. Our p-value here is 0.20, 0.2038. if you round it to 4 decimal places, which is what the book wants. So, what is the null hypothesis and what can you conclude about it? Well, remember the null hypothesis is always an equal sign. In this case, the null hypothesis will be that the number of people with headaches will be 0.11. So the number of people with headaches is 0.11. That's your null hypothesis. And so let's keep going. What is the final conclusion of the test? Do we decide? Well, I've missed a question, so let's answer this one. Do you think we should reject the null hypothesis or not? What do you think? Here was our p-value of 0.2038, and our alpha significance level was 0.01. Notice here that the 20% is greater than alpha. So that means that we failed to reject the null hypothesis because because alpha was greater than wow, the book has it backwards. Yeah, our p-value was larger than alpha, and so we failed to reject. Think about it this way. We always want our p-value to be really, really small. We want our p-value to be so small that it's smaller than alpha. If the p-value is greater than alpha, then that means we fail to reject. So we found that there is not going to be sufficient evidence to reject the null hypothesis, and that's what this first answer choice says. There is not sufficient evidence to support the claim that less than 11% of treated subjects experienced headaches. So we failed to reject the null hypothesis. We didn't prove the null hypothesis, we just failed to reject it, and so maybe we should do another test if we're still suspicious. Basically what just happened was, although 0.09 was less than 0.11, it wasn't different enough that we could reject the null hypothesis. There's a 20% chance we could have gotten 0.09 just by luck, and this test was demanding only a 1% chance of that happening, so we failed to reject. I know this all gets a little bit confusing, and it even confuses me sometimes, and especially when I'm trying to explain it. So hopefully it's starting to come together. We'll look at another example here in the next video.